All right, here we have a similar exercise. We know that x, y, and z are midpoints of AB, BC, and AC. I'm assuming respectively. So let's see. So x is midpoint of AB. So those are congruent. Y, midpoint of BC. So those are congruent. And then similarly, z is the midpoint of AC. So those are all congruent, right? So we know that here, let's start. If AC is 24, then XY equals what? So AC is 24. XY is going to be half of that, right? So XY would be 12. All right. Next, if AB equals K, so AB, if that equals K, then YZ will be half of K, right? So it'll be, you can put 1/2 K, or, oops, that's not a K. Or you can put K over 2. All right, XZ is 2K plus 3. So XZ, 2K plus 3. Then BC is half, or BC is double that, right? So BC would be 2 times 2K plus 3. Don't forget the parentheses, right? Because it's double. So I don't know if, depending on how they want the answer formatted, you could also distribute and get 4K plus 6. Either way would be fine. Yeah, either way would probably be fine with me there. So D, AB is 9. So AB is 9. BC is 8. And AC is 6. Then the perimeter of XYZ, right? So that'll be the sum of half of all these, right? So it'll be AB is 9, so that means XZ is half of 9, which is 4.5. BC is 8, so that means that XZ is going to be half of 8, which is 4. AC is 6, so that means XY will be half of that, which is 3. So if we add all those up, 3 plus 4 plus 4.5, we get 11.5. Okay. All right. So this next one is saying, okay, well, if the perimeter, forgot to erase that before I moved on. If the perimeter of XYZ is 24, then the perimeter of ABC is going to be what? Well, remember, each of these sides is half of each of these sides, respectively, right? And so, so that means the perimeter here is going to be half of this perimeter, all right? So if we just double this, we should get the perimeter of this, right? So that's 48. All right, then it says name all the congruent triangles. So let's see. Congruent triangles. So we know this is, well, we know we can use these values here, but like if these are the values here, then that means that these are the values here, right? Okay, so we can see that we already know that these are congruent, these are congruent, these are congruent, right? So let's just start with this triangle here. And we know that this is congruent with this, right? So let's do those two triangles. And then we know that this is 3 and this is 3, right? So that means that this is congruent with this, right? So that means those triangles are congruent by side, 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 right? So XBY is congruent with triangle AXZ, right? Okay, let's see what else. So let's stick with those two. Oh, and I forgot to do these two, right? I didn't actually do side, side, side. Let's double check one more time. So this is 4 and this is 4, so that means those must be congruent as well, right? So yeah, so it is side, side, side. Okay. All right, and now that we have this, let's see what this is congruent to, and then we can just kind of connect them all. So 4.5 is the same as this, right? So that means this side is congruent to these sides. So I'll put one little tick mark there. And so now you can see that all these triangles are congruent, right? By side, side, side. So we can continue this congruency statement and say that also triangle, let's do it like that, triangle, let's make sure we put these in the right order, XBY and AXZ, I did that one right. So then these ones are a little easier to orient, so we'll do Z, Y, C. And then the last one, this one's kind of upside down, so it's a little bit trickier. So we started with A, which is the 1 tick mark with the 3 tick mark. So that's going to be this Y here, triangle Y. And then we went up to X, which is the one with the 1 and the 2 tick mark. So that's going to be Z here. And then the last side, vertex is X, so ZYX. All right, so all those are congruent with one another.